Okay, I want to do another video for 6.3 just over a word problem so you can kind of see how these things work. Let's say that you're asked to find the component form of a vector that represents the velocity of an airplane descending at a speed of 100 miles per hour at an angle of 30 degrees below the horizon. Now, your book may or may not have this word problem. I'm working on my videos using another textbook by the same publisher that sometimes has some of the things you do and sometimes they don't. So you might find this in the book. I'm not sure. Okay, if we look and we think about this problem, drawing a picture is going to help us figure out what to do here. If you put this on the axis, now the velocity is 100 miles per hour. That's the speed at which it's descending at. That's going to be the magnitude of our vector. The magnitude is the speed plane is descending. The speed at which the plane is descending. I'll put at which. I'll just use the at symbol there. Y'all all know what that means, which is descending. Okay? So, if the plane's going down and it's, to figure out where we're going to draw it, though, we've got to look at the other part of it. It's 30 degrees below the horizontal, and there's a picture of this that I'm looking at, but in case you don't have the picture, it's like this. Let's say the length of that vector, let's say that's the vector first, and that the length of that vector is 100, and it's at this 30 degrees below the horizontal. So that angle right there is 30 degrees. The problem is I want to write this in component form. And component form, if you remember, is when we write it with the i's and the j's. Okay? Now, what am I going to do? Because the component form of this vector would be ai plus bj, but how am I to find the a and the b? Okay, well, if you also remember, another form that we had of it, in another component form we had, was that it was A was basically the magnitude of the cosine of the angle times I. I'm going to put the I in a different color just to emphasize. Well, that didn't work, did it? Oh, well, I won't do it then. Plus the magnitude of the sine of the angle times j. And if you remember, this is the magnitude times the cosine gives us the x value part of the component, which is our a. And the magnitude of the vector times the sine gives us the y value part, which is what is the coefficient of our j there. Alright, so in order to think about this, our angle is really not 30, is it? Don't we measure angles from the positive x-axis? So if I'm measuring my angle, I got to think about it's really this. So we know that this much, if it's 180 plus 30 is 210. What we can do is, if we want to figure this out, we know that the vector is the magnitude of v. Well, what is the magnitude? We said that was 100, wasn't it? That was that speed. And now it's the cosine. It's 100 times the cosine of 210 degrees. And that's what goes in front of the I. And then in front of the j part goes that magnitude again. Well, the magnitude is the speed. Speed is vectors can be used to represent speed. So it's 100 because that's the speed. And then we want the sine of 210 degrees, and that's what goes in front of our j. So really all we got to do is find the cosine of 210 and the sine of 210, and we'll be able to figure this out pretty easily. We have a 30-degree reference angle, and so the cosine is just the x component, which would be right here. So if it's 30 degrees, here's the 30-degree angle. I'll put a big dot because I got a little dot there accidentally. Didn't mean to do that. This is the across from the 30 degrees. We call it x, or 1x, all right. Across from the 60 degrees, we know this would be the right angle. So 60 degrees would be here. Across this would be x squared of 3, and this would be 2x. And what we do know is that if we write that like this, we just need the number parts to get our cosine value. So our cosine is the square root of 3. Okay, so this is 100 times, it's square root of 3 over 2, I'm sorry. Cosine is adjacent over hypotenuse. So it's square root of 3 over 2. Okay, so it's 100 times square root of 3 over 2. I'll just make it one fraction like that. Times I. And now let's do the y part. I'll put it in a different color, okay? I'm sorry, the y part is the coefficient of this j right here. So it's 100, and the sine of 30 degrees. Ooh, I need to remember something. All students take calculus. In this quadrant, the tangent's positive, but the sine and the cosines are going to be negative. So this is actually going to be a negative over here because it was the cosine, and over here we're going to also have a negative. I'm just going to stick the negative out front. What is the sine? It is opposite, which is 1, over hypotenuse, which is 2. So it's 100 times a half, or if you want to think about it, it's just 100 divided by 2, because 100 times 1 is 100 divided by 2. That's going to be negative 50 in front of the j, isn't it? So that was, let's see, that's going to be a minus 50j. I'll just go ahead and simplify that one since it was easier. Now let's come over here to the first part. I didn't simplify it when I did it. 2 goes into 2 once, 2 goes into 150 times, so it's negative 100. Why did I write 100? Let's see if I can undo that. 100 divided by 2 is 50, negative 50, square roots of 3i minus 50j. You remember, you can also write it, that's equivalent to writing it this way. That's the component form. Here is just the regular vector form. Negative 50 square roots of 3 comma negative 50. So that would be the vector that would represent that. That would be the vector that represents that word problem.